Usually, when we talk about a mystery, we picture a crime scene, like a locked room, maybe.
Right, a classic whodunit.
Exactly. Fingerprints, a timeline, a detective with a magnifying glass trying to piece together this really highly localized puzzle. There is this expectation of proximity.
Yeah, cause and effect.
Right. The cause and the effect are just right there in the same room. You drop a glass, it shatters at your feet, you strike a match, the flame is right in your hand.
It's a contained system. I mean, cause A leads directly to effect B, and you can draw a very short, very straight line between them. Our brains are essentially, hardwired to understand the world through that kind of localized cause and effect.
But I want to throw you, and by you I mean everyone listening right now, into a scenario that completely breaks that hardwiring.
Okay, I'm ready.
Picture this. Transport yourself to the morning of August 27, 1883. You are standing on Rodriguez Island.
Which is, pretty out there.
Yeah, for the sake of setting the scene, this is an incredibly remote spot in the middle of the Indian Ocean.
Yeah.
I mean, it's a tiny volcanic outcrop hundreds of miles east of Madagascar.
Basically the middle of nowhere.
Exactly. It is a quiet, totally ordinary morning. The sounds you hear are just the daily, localized ambient noise. The wind coming off the water, maybe a bustling local market, the creak of wooden boats in the harbor.
It's everyday life.
Right. And then the local police chief, a man who knows this island intimately, hears something that just completely shatters that ordinary morning. He hears a deep, rolling, thunderous boom.
And we know from the historical record, the sources we're looking at today, that this wasn't just a vague atmospheric rumble.
No, not at all.
The chief noted that it sounded unmistakably like distant naval gunfire.
Which is terrifying.
Oh, absolutely. To a colonial officer in 1883, that sound had a very specific, menacing implication. It sounded like a massive naval battle was taking place just over the horizon.
But, and here's the crazy part, there is no battle.
Yeah.
There is no navy anywhere nearby. There are literally no ships firing cannons.
Nothing on the radar. Well, no radar back then, but you get the point.
Right, exactly. There is absolutely no visible source for this sound anywhere on the ocean. It is a sensory input that completely defies the reality of the person experiencing it. That police chief is hearing an impossible sound.
Well, the source of that sound wasn't just over the horizon. It was coming from a distance that essentially breaks our intuitive understanding of how acoustic energy operates in the physical world.
Yeah.
That deep, rolling boom heard on Rodriguez Island had traveled roughly 3,000 miles.
Wait, hold on. 3,000 miles.
3,000 miles.
That is like roughly the distance from New York to Los Angeles.
Yeah.
I need to push back on this for a second, because if I scream at the top of my lungs, you can't hear me 2 blocks away.
Right. Definitely not.
How does a sound physically maintain enough acoustic integrity to travel across an entire ocean without just dissipating into the wind?
That is the perfect question, really, because to understand that, you have to understand that this wasn't just a loud noise.
Right.
It wasn't just an acoustic wave created by two things banging together. What that police chief was hearing, carried across an entire ocean by the sheer physical displacement of the atmosphere itself, was the sound of a volcanic island literally tearing itself apart.
Wow.
He was listening to the catastrophic eruption of Krakatoa.
And the mission of our deep dive today, going through all our provided sources, is to unpack exactly how that happened.
Yes.
We are going to explore how this single geological event produced what scientists widely consider the loudest sound in recorded human history. We're going to look at how it triggered a devastating human tragedy, and surprisingly, how it birthed the modern concept of global breaking news.
It's just massive. We are looking at a singular moment in history where massive geological forces, atmospheric physics, unimaginable human tragedy, and early modern technology all collided.
It's like a perfect storm.
Exactly. It's a moment that had never happened before, and in many ways, it fundamentally set the template for the interconnected world we live in right now.
And that is exactly why this matters to you listening right now. You have probably heard the name Krakatoa tossed around.
It's a great piece of historical trivia.
Right. Maybe you know it was a big volcano that blew up a long time ago. But what we are going to reveal today, pulling from a variety of historical and scientific sources, is how this specific event permanently altered how humanity experiences distant catastrophes.
It changed everything.
It really did. We are going to draw a direct, undeniable line from this 1883 eruption to the very way you consume news, receive push notifications, and process global trauma today.
To really understand the scale of this paradigm shift, though, we have to start before the explosion.
Yeah, the buildup.
Right. We have to look at a volcano that the world barely knew and a society that completely underestimated it. To set the scene properly, we need to look at the geography and the geopolitics of the era.
Okay, paint a picture for us.
So, if we look at a map of Southeast Asia, specifically the Dutch East Indies, which is present-day Indonesia, we find the Sunda Strait.
Which is a pretty crucial waterway, right?
Extremely crucial. It acts as a geographic bottleneck. It runs right between the massive, densely populated coastlines of two major islands, Sumatra to the north and Java to the south.
Okay.
And sitting right there, right in the middle of that strait, was Krakatoa.
But it wasn't some mythical hidden island shrouded in mist or something, right? Like, the Sunda Strait was one of the busiest shipping lanes in the world.
Oh, far from hidden. It was a major artery for global commerce. The Dutch colonial empire relied heavily on this route for the spice trade, coffee, sugar, and tobacco.
So people definitely saw it.
Hundreds of ships passed through there. People knew Krakatoa was there. It was a small, largely uninhabited archipelago consisting of three main volcanic peaks.
And did they know it was a volcano?
Yeah, they knew it had a history of volcanic activity. There were records of it erupting centuries earlier. But prior to 1883, it simply wasn't considered an urgently monitored or especially prominent threat by the standards of that era.
Let's talk about those standards for a second, because if the Dutch had all this wealth flowing through this strait, why wasn't there any kind of robust warning system?
Well, you have to.
Like, if this was a known volcano in a massive trade hub surrounded by coastal villages, you'd think they would be keeping a very close eye on it.
You really have to look at the socioeconomics of colonial administration based on the historical sources. The Dutch East Indies was governed primarily for the purpose of extraction and profit.
Right.
The infrastructure, the ports, the roads, the telegraph lines, was built to facilitate trade and maintain administrative control. It was not built to protect the local indigenous populations living in the coastal kampongs or villages.
So public safety wasn't exactly the priority.
Exactly. The warning infrastructure for the densely populated coastal communities along Java and Sumatra was practically non-existent. There was no scientific mandate to monitor seismic activity for public safety.
Plus, there were no satellites, obviously.
Precisely,
There
yeah.
were no seismologists monitoring underground magma chambers 24/7 with digital sensors like we have at Yellowstone or Mount St. Helens today.
Nothing of the sort. The only monitoring system they had was human observation.
Just a guy looking at a mountain.
Literally just looking out at the mountain, seeing what it was doing. And that visible evidence started getting very, very aggressive in May of 1883.
Walk us through that timeline, because this wasn't just a sudden overnight explosion, was it?
Not at all. Beginning in May, Krakatoa entered a prolonged, escalating period of volcanic activity.
So it was ramping up.
Yes, significantly. On May 20th, a German warship passing through the strait reported a massive ash cloud rising over 6 miles into the sky.
6 miles? That's incredible.
And the rumblings were so loud they could be heard in Batavia, modern-day Jakarta, which was roughly 100 miles away.
Wow.
Windows rattled, doors shook. This wasn't a subtle warning sign.
So we have a mountain in a narrow strait, right between two heavily populated islands, suddenly spewing ash 6 miles high and rattling windows 100 miles away. Logically, you would think this is the moment everyone panics, packs their bags, and heads for the hills.
You would think so. But human psychology is incredibly complex when dealing with slow-moving, unprecedented threats. What actually happened is a textbook example of a phenomenon we call creeping normalcy.
Creeping normalcy, what exactly is that?
Yes. It's a psychological mechanism where a major unacceptable change is accepted as the new normal because it happens slowly over time rather than in a single sudden shock.
Oh, okay, like boiling a frog.
Very similar, yeah. The local populations on Java and Sumatra had lived alongside the region's volcanic activity for generations. The Ring of Fire is highly active. A rumbling volcano wasn't an anomaly. It was part of the landscape.
It was just a Tuesday for them.
Pretty much. And for the Dutch colonials in Batavia, it was just another interesting facet of the exotic environment they were administering.
So the ash and the rumbling just became background noise?
Actually, it was worse than that. It became entertainment.
Entertainment? You're kidding.
I wish I was. Instead of mass evacuations, the escalating activity actually drew curious sightseers. Enterprising locals and colonials were literally chartering steamboats to go out into the Sunda Strait to observe the ash plumes up close.
Are you serious?
Yes, they threw parties on these boats. They marveled at the lightning storms that were being generated inside the ash clouds.
It is so wildly relatable, though.
How so?
It's like Krakatoa in May 1883 was a blaring red check engine light on the dashboard of the planet. And instead of pulling the car over and running for safety, society not only ignored the light, they actively leaned in to take a sightseeing selfie with it.
That is a perfect analogy.
We have this historic, deeply ingrained inability to gauge unprecedented natural threats until the absolute final second.
We normalize the warning signs because the alternative is simply too disruptive. Acknowledging that your entire environment, your home, your livelihood is about to be radically, violently altered. That requires a level of psychological acceptance that most people just resist.
It's too much to process.
Exactly.
Yeah.
So they take the boat ride, they watch the ash, they assume tomorrow will be exactly like yesterday because up until that point, it always had been.
They assumed the mountain was just putting on a show.
Right.
But that creeping normalcy was about to be violently shattered. The check engine light wasn't a glitch. The engine was about to catastrophically fail.
It really was.
Which brings us to the end of August. Let's move into the actual physical event that the sources detail.
Yes. By late August, the activity had reached a fever pitch. On August 26, the mountain entered its paroxysmal phase.
What does that mean exactly?
It means a continuous, deafening roar with ash blocking out the sun entirely for miles around. But the true catastrophe occurred on the morning of August 27, 1883.
The big day.
Right. And Krakatoa didn't just erupt in the way we typically imagine, like a mountain slowly oozing a river of red lava. It produced a terrifying sequence of 4 major explosive eruptions.
What exactly causes a mountain to blow up rather than just leak lava? Because there's a big difference between like a Hawaiian volcano that tourists can watch safely from a few hundred yards away and what happened to Krakatoa.
It all comes down to the geology of the magma and the physical geography of the island.
Okay, break that down for us.
Hawaiian volcanoes generally have basaltic magma, which has a low silica content. It's runny. Gases can escape easily, so it kind of just bubbles and flows.
Like a pot of soup boiling over.
Good comparison. But Krakatoa sits on a subduction zone where the Indo-Australian tectonic plate is diving under the Eurasian plate. This creates magma that is highly rich in silica. It is incredibly thick and viscous.
So it acts like a plug.
Exactly like a plug. Because it's so thick, the massive amounts of volcanic gases expanding inside the magma chamber can't escape.
Throw me in.
The pressure builds and builds until the rock simply cannot contain it, resulting in a violent, explosive release. But Krakatoa had an additional fatal ingredient. It was an island.
Water.
Massive amounts of seawater. As the initial eruptions on August 26th and 27th fractured the structure of the island, millions of tons of ocean water poured directly into the superheated magma chamber below.
That sounds like a recipe for disaster.
It is. When cold seawater meets magma that is over 1,000 degrees Celsius, it flash boils instantly into steam.
And steam expands rapidly.
It expands to roughly 1,700 times its original volume in a fraction of a second.
Whoa.
This is called a phreatomagmatic eruption. It is one of the most violent physical processes on Earth. The combination of the expanding volcanic gases and the flash-boiling seawater essentially turned Krakatoa into the largest geological pipe bomb in human history.
So we have these 4 blasts on the morning of August 27th.
Yes, at 5:30 a.m., 6.44 a.m., 10.02 a.m., and 10.41 a.m. The third blast at 10.02 a.m. was the catastrophe.
Also the big one.
The biggest. The magma chamber beneath the island essentially emptied itself of an estimated 20 cubic kilometers of rock and pumice with such violent force that the structural integrity of the entire island failed.
Just blew it all out.
Completely. A massive portion of Krakatoa simply collapsed, falling back down into the ocean, into the empty, superheated void below.
I really want to pause here and just think about the sheer mechanics of that collapse.
Yeah.
You have a mountain, it blows its top, emptying its foundation, and then the sheer weight of millions of tons of solid rock collapses downward into the sea, forming what geologists call a caldera.
Exactly.
But when you displace that much water instantaneously, the ocean doesn't just absorb it, the ocean reacts.
And that reaction was the true agent of death. We have to shift our focus entirely away from the fire and the ash and look at the water.
Right.
The collapse of the island generated a series of tsunamis that just defy human comprehension.
I want to clarify something about tsunamis, because I think a lot of people picture them as just really big surfing waves, a huge wall of water that breaks on the beach. But that's a wind-driven wave. A tsunami is completely different, isn't it?
Fundamentally different, yes.
Mm.
A wind-driven wave is just energy moving through the surface layer of the water. The water itself isn't traveling horizontally, just the energy.
Right.
But a tsunami is a displacement wave. When that much island mass enters the ocean, or when the seafloor drops out, it physically pushes the entire water column from the ocean floor all the way to the surface, outward in a massive ring.
So it's not a wave on top of the ocean. It is the entire ocean moving at once.
Yes, exactly. In deep water, a tsunami might only be a few feet high, but it travels at the speed of a commercial jetliner over 500 miles per hour.
That is terrifyingly fast.
And as it approaches the coast and the seafloor becomes shallower, all that kinetic energy has nowhere to go but up. The wave slows down, and the back of the wave catches up with the front, piling the water up into a terrifying surging wall.
And historical records from the Sunda Strait put the height of these waves at over 30 meters. That is roughly 100 feet tall.
Imagine a 10-story building made entirely of fast-moving, churning ocean water, packed with the jagged debris of a shattered island. Coral reefs that were ripped from the seafloor and superheated pumice, and it is hurtling toward a densely populated coastline.
It is absolute nightmare fuel. And the human toll was devastating. The coastal towns and villages on Java and Sumatra, places like Anjer and Merak, where people had just weeks earlier been casually watching the ash plumes from their verandas,
Right.
they were completely obliterated.
Yes.
With the communication infrastructure of the time, there was absolutely no warning. Even if you saw it coming, you couldn't outrun it.
The destruction was total. The coral blocks thrown on shore weighed up to 600 tons. Whole towns were swept away, leaving literally only the bare bedrock behind.
Unbelievable. What were the numbers like?
Well, the official minimum estimate, and we must stress that this is a universally accepted minimum in the sources, as colonial records often severely undercounted indigenous populations, is that more than 36,000 people died.
And that's just the minimum.
Right. Some modern historians argue the true number could be much closer to 120,000.
I really want to challenge the popular cultural memory here. When you say the word Krakatoa to someone today, they immediately picture an apocalyptic sky.
Yeah, the classic volcano image.
Right. They picture fire, magma, skies choked with black smoke and lightning. It is ingrained in us as a story of fire and ash. But when you look at the actual forensic data of the tragedy from these historical sources, the true story of Krakatoa is fundamentally a story about a wave.
It absolutely is. The overwhelming majority of those victims were killed by the tsunamis, not by the volcanic blast itself.
Right.
The pyroclastic flows, those superheated avalanches of gas and ash, did claim lives, particularly on a neighboring island where over 1,000 people were essentially flash fried.
Which is horrifying on its own.
It is. But the water was the primary executioner.
It is a tragic, bitter irony. The most spectacular visual and auditory geological event in recorded history was happening. This unbelievable explosion of fire and rock. But the thing that actually killed the vast majority of its victims was silent, fast-moving water.
Yeah.
By the time they saw the water recede from the shoreline, drawing back to build the wave, it was already over.
The fire was the spectacle, but the water was the reality. But while that literal wave of water was doing its terrible work on the coastlines of the Sunda Strait, a second type of wave, an invisible wave, was simultaneously escaping the atmosphere and heading out to introduce Krakatoa to the rest of the world.
Which brings us back to our police chief on Rodriguez Island, 3,000 miles away.
Exactly.
Because that second wave, the pressure wave, is what makes this event entirely unique in the historical record.
Let's unpack the physics of that atmospheric wave and answer your earlier question about how a sound can travel that far without losing its integrity.
Yes, please.
When Krakatoa collapsed in that 10.02 a.m. explosion, it displaced not just rock and water, but an immense volume of air. It violently shoved the atmosphere out of the way.
Like blowing up a balloon inside a shoebox until the box bursts?
A good analogy, but on a planetary scale. It pushed the air outward with such sudden violence that it created a shockwave.
Okay.
This wasn't just an acoustic sound wave like my vocal cords vibrating the air right now. This was an infrasonic pressure wave.
Infrasonic meaning below human hearing.
Exactly. It carried so much low-frequency energy that it maintained its cohesion over vast distances. As it passed over populations, the low-frequency pressure variations caused buildings to shake, which people interpreted as the booming sound of heavy artillery.
So the police chief wasn't necessarily hearing a bang like a firecracker. He was feeling a massive fluctuation in air pressure that his ears interpreted as a physical boom.
Precisely. The final explosion generated a pressure wave that essentially refused to dissipate. It was so energetic that it didn't just cross the Indian Ocean to Rodrigues Island. It continued.
It kept going.
This invisible wall of compressed atmosphere traveled outward in all directions, and we have the physical documented evidence to prove it. This wave circled the entire globe.
And it didn't just circle it once, right? The sources say it kept going.
No, it circled the globe multiple times. It went out, converged on the opposite side of the planet, an area in the country of Colombia, specifically bounced back and did another lap.
Wait. I want to make sure I understand this. The wave hit the exact opposite side of the globe, converged on itself, and then rebounded back the way it came.
Yes. Think of dropping a massive boulder into a perfectly round, calm pond. The ripples travel outward in expanding circles until they hit the edges of the pond. Then they reflect back inward, crossing over each other.
Ah, I see.
The Earth was the pond, Krakatoa was the boulder, and the atmosphere was the water carrying those ripples.
Okay, that visual makes perfect sense. But here is the mind-bending part of this story for me. We know this happened because of the barometers.
The barometric data is the true scientific smoking gun of Krakatoa.
A barometer, of course, measures atmospheric pressure.
Right. And in the late 19th century, scientists, meteorologists, and weather stations across the world, in London, New York, Tokyo, St. Petersburg, were actively monitoring and recording these instruments on rotating paper drums called barographs.
So days after the eruption, you have a scientist in London. There is no ash in the sky. There is no sound to be heard. It is a totally normal, quiet day in England. But suddenly, the ink needle on their barograph physically jumps.
The needle spiked sharply upward, then dropped, marking the exact moment the ghost of Krakatoa's explosion washed over the British Isles.
Wow.
The atmosphere above London literally compressed and expanded, and then, roughly 36 hours later, the needle jumped again as the wave completed another lap around the planet.
That is wild.
Some stations recorded the wave passing up to 7 times before it finally lost its energy.
That is staggering. The entire Earth was ringing like a bell, and they had the paper receipts to prove it. But here's my question. If we have all these Victorian scientists scattered thousands of miles apart, looking at their twitching barometers on different days, how did they even realize they were all recording the same event?
That is the pivotal question that bridges geology and human history.
Right, because how would they know?
Because 50 years prior to this, they wouldn't have known. A scientist in London would have recorded a strange pressure anomaly, filed it away in a journal, and maybe years or decades later compared notes with a scientist in America or Asia.
It would just be a weird coincidence.
The connection would have been a total academic afterthought.
Yeah.
But in 1883, the world had fundamentally, structurally changed. They were able to connect the dots almost immediately because of a brand new, invisible web that had just been laid across the ocean floor.
The Telegraph network.
Yes. By 1883, humanity had achieved a monumental engineering marvel. We had successfully laid down a growing global network of undersea telegraph cables.
I really want to dig into how miraculous this was for the time, because I think we take it for granted today. Laying an undersea cable in the 1800s wasn't just dropping a wire off the back of a boat.
Not at all.
It was an incredibly fraught, highly experimental process based on the engineering documents from the time.
It was a massive technological undertaking. They had to manufacture thousands of miles of copper wire, insulate it with gutta percha, which is a naturally occurring latex from trees in Southeast Asia, ironically.
Wait, tree sap?
Basically, yes. It was the only material they had that could insulate against seawater.
That's crazy.
Then they wrap it in iron armor and then load it onto specially designed ships that would slowly spool it out across the abyssal plains of the oceans.
And it didn't always work, did it?
No, the early attempts, like the first transatlantic cable in 1858, failed miserably after a few weeks. But by the 1870s and 1880s, the engineering had matured.
So by the time Krakatoa erupted,
Yeah.
this network was actively buzzing.
It connected much of Southeast Asia, including Batavia, to Europe via India and the Middle East. And from Europe, the cables ran under the Atlantic to North America. We had essentially, for the first time in human history, wired the planet's major imperial and commercial centers together.
This is a total paradigm shift in human consciousness. Think about the speed of information before this. The speed of news was strictly limited by the speed of a horse, a train, or a sailing ship.
Right, physical transportation.
If a volcano erupts in the Sunda Strait in, say, 1830, the only way London finds out about it is if a ship physically sails from Java around the Cape of Good Hope all the way to England. That takes months.
The disaster would have been historical trivia by the time the news arrived. A tragedy relegated to the back pages because it happened a season ago.
But contrast that old world with the new reality of 1883. Because of those undersea cables, news of the Krakatoa eruption, the destruction of the towns, the terrifying tsunamis, it didn't travel at the speed of a ship.
It traveled along electrical wires beneath the oceans at the speed of light.
Which is mind-blowing for 1883.
Reuters and the Associated Press were actively utilizing these cables. The news reached major newspapers in cities like London, Paris, and New York within roughly a single day of the event.
A single day. From a remote strait in the Dutch East Indies to a newsboy yelling on a corner in New York City. This is why media historians in our sources point to Krakatoa as a monumental milestone.
Absolutely.
It was the first distant natural disaster experienced by a global reading public as something close to real-time breaking news.
It is the absolute birth of the modern news cycle. For the first time in human history, millions of people, separated by oceans, were collectively reading about and reacting to a catastrophic event almost as it was happening.
It completely collapsed the geographic distance between isolated societies.
Did
Put yourself in the shoes of a citizen in 1883.
Yeah.
You're used to a world where history only happens in the past tense. You only hear about wars long after the treaties are signed. You only hear about disasters after the victims are buried and the towns are starting to rebuild. And suddenly, overnight, you are walking down the street in London, you buy a paper, and you're experiencing tragedy on the other side of the planet in the present tense.
The psychological impact of that sudden, instantaneous awareness of global suffering cannot be overstated.
It is the 1883 equivalent of receiving your very first smartphone push notification. Imagine never having a phone, and suddenly it buzzes in your pocket to tell you a mountain just exploded in Indonesia and the death toll is rising by the hour.
That instantaneous connection transformed a regional tragedy into a shared global event. People in New York or Paris weren't just passively reading a history book, They were anxiously awaiting the next Telegraph update to see if more tsunamis had struck or if the ash cloud was spreading.
Yeah.
It generated a level of immediate global empathy and global anxiety that simply hadn't existed before.
But the connection to Krakatoa wasn't just words on a page, delivered by Morse code.
No, it wasn't.
Readers in London or New York didn't just read about the volcano. Within months, they could look up and physically see the evidence of it in their own skies. The eruption didn't just send a pressure wave and a telegraph signal. It sent physical pieces of itself across the globe.
Which brings us to the environmental aftermath, which was spectacularly visible and scientifically profound. When Krakatoa exploded, it didn't just throw ash into the troposphere, which is the lower layer of the atmosphere where our weather happens.
Right, because if it had, rain would have washed the ash out of the sky relatively quickly.
Exactly. But it went much higher than that. The sheer kinetic force of the 10.02 AM blast injected unimaginably huge quantities of volcanic ash and, crucially, sulfur dioxide gas straight up into the stratosphere.
Now, the stratosphere is above the weather. There's no rain up there to wash things away. But why does that matter so much? What makes the stratosphere act like a global highway?
It has to do with convection. In the lower atmosphere, warm air rises and cold air sinks, which creates clouds, storms, and rain. But the stratosphere is stratified, meaning it gets warmer the higher you go, largely due to the ozone layer absorbing UV radiation.
Okay, so it's upside down from what we're used to.
Basically, because warm air is already on top, there is very little vertical mixing. The air is highly stable vertically, but it features powerful horizontal winds.
So once the sulfur dioxide gas was injected up there, it was essentially trapped on this high-speed horizontal conveyor belt.
Precisely. It caught those high-altitude atmospheric currents. Over the following weeks and months, this massive cloud of aerosolized particles circulated the entire globe.
Wow.
And it had two major, highly documented effects. The first was a measurable global climate impact.
Let's break down the chemistry of that, because it's not just the dark ash blocking the sun like a blanket, is it?
No, the heavy ash actually fell out relatively quickly. The real climate culprit was the sulfur dioxide gas. Once in the stratosphere, the sulfur dioxide reacted with water vapor to form tiny droplets of sulfuric acid. These are known as sulfate aerosols.
And what do these aerosols do?
They are highly reflective. They essentially formed a microscopic, shiny veil around the Earth that reflected a significant portion of incoming solar radiation back out into space before it could warm the surface.
Okay.
This is a concept known as albedo.
So the Earth's reflectivity increased. which means the planet absorbed less heat.
Exactly. As a result, there was a measurable global temperature dip in the year following the eruption. Modern analysis suggests average northern hemisphere summer temperatures fell by as much as 1.2 degrees Celsius.
1.2 degrees might not sound like a lot to someone listening, but in climatic terms, that is a massive, highly disruptive drop.
It was incredibly disruptive. There were widespread reports of unseasonal weather, crop failures, and torrential rains in places like California. It is a stark, undeniable proof of how a localized geological event can dramatically alter the planetary climate system.
But the second effect of those stratospheric aerosols was the one that caught everyone's attention, because it was so visually stunning.
Yes, the visual spectacle of the sunsets. The sulfate aerosols and remaining fine ash particles in the stratosphere scattered sunlight in a very specific physical manner known as Rayleigh scattering.
Can you explain how that scattering actually paints the sky?
Sure. So sunlight contains all the colors of the visible spectrum. When the sun is high overhead, the light passes through a relatively thin layer of atmosphere and shorter wavelengths like blue scatter, making the sky blue.
Right, standard daytime sky.
But when the sun sits low on the horizon during sunrise and sunset, its light has to pass through a much thicker horizontal slice of the atmosphere.
And when you add a global layer of volcanic aerosols to that thick slice,
The particles filter out and scatter the shorter blue and green wavelengths completely, allowing only the longer, more penetrating wavelengths, the brilliant reds, oranges, and deep purples, to pass through to the observer on the ground.
and historical accounts describe these unusually vivid, intensely colored red and orange sunsets being heavily documented all across Europe, North America, and beyond.
Oh, yeah.
I read in the sources that fire engines were literally called out in places like New York and London because the glow on the horizon was so intensely red, people genuinely believed neighboring towns were burning to the ground.
It's true. The skies were described as looking like bruised flesh or liquid fire. It was so profound that it deeply influenced the art and literature of the period. Lord Tennyson wrote poems about the blood-red skies.
Which introduces one of the most fascinating hypotheses about Krakatoa's cultural impact from our deep dive today. We have to talk about Edvard Munch and his famous 1893 painting, The Scream.
A classic.
For anyone listening, you know the image immediately. It's the agonizing, hairless figure holding its hands to its face in a silent scream, standing on a bridge against this incredibly menacing, swirling, blood-red sky.
The sky in that painting isn't just a passive background. I mean, it is an active, oppressive presence that seems to be causing the figure's existential dread.
And many researchers, physicists, and art historians have proposed that the blood-red sky in the Scream was directly inspired by the atmospheric effects of Krakatoa that Munch would have personally witnessed in Oslo, Norway, a decade earlier.
We do need to carefully caveat this, though, because art is inherently subjective.
Of course.
It is a highly plausible and intensely debated connection. Munch wrote in his journals about a specific evening where the sky suddenly turned blood red and he felt a great unending scream piercing through nature. Skeptics argue it was a purely psychological landscape, or perhaps inspired by local nacreous clouds. But the fact that this debate exists at all, that scientists analyze the specific chromatic values of the paint Munch used to see if it matches volcanic scattering, underscores just how deeply those Krakatoa sunsets permeated the cultural consciousness of the Western world.
Let's unpack that cultural consciousness, because I think it highlights the massive shift that occurred. Imagine you are a person looking at these terrifying, bleeding red skies in London or Oslo.
Right.
Because of the Telegraph, because of the breaking news we talked about, you actually knew why the sky was turning those colors. You knew a volcano in the Sunday Strait had exploded and sent ash into the atmosphere.
You had context.
Exactly.
Yeah.
But it makes me wonder, if Krakatoa had happened 50 years earlier, before the Telegraph, before a global media network, would people have just thought the world was ending?
It's a brilliant point, and it really highlights the relationship between information and fear. If a medieval or early 19th century society suddenly experienced months of blood-red skies, strange halos around the sun, and a noticeable drop in global temperatures leading to crop failures, with absolutely no context or explanation.
It would have been interpreted through a lens of apocalyptic terror, wouldn't it?
Almost certainly. Apocalyptic terror or divine retribution.
It would have been terrifying. You'd look up, the sky is bleeding, your crops are dying, and your local religious leader is telling you it's the end of days.
But because of the Telegraph, the terror of the unknown was replaced by the shock of the known. The phenomena were contextualized. They knew the sky was red because of a mountain in the Dutch East Indies. That information didn't make the red skies any less spectacular, but it shifted humanity's reaction from superstitious panic to scientific curiosity.
And that scientific curiosity is exactly what Krakatoa left behind as its enduring legacy. It wasn't just a sensational news story. It was a catalyst for a new way of understanding the Earth.
Absolutely. The eruption of Krakatoa birthed the modern era of global collaborative science. Following the event, the Royal Society in London formed a special committee to compile all the global data.
And think about what they had at their disposal.
It was unprecedented.
They had the barometric pressure readings from weather stations worldwide, all recording the exact same atmospheric wave passing multiple times.
They had meticulous reports of unusual sunsets, atmospheric optics, and temperature drops collected from ship's logs and city observatories around the entire planet. They had telegraph records coordinating the precise timing of these events across different time zones.
So for the first time in history, scientists weren't just looking at their own localized backyards and extrapolating. They had a genuinely global data set to work with.
This specific event directly advanced the early scientific understanding of atmospheric science. It proved definitively that the Earth's atmosphere was a single, interconnected fluid system and that the high-altitude jet streams existed.
That's huge.
It also birthed modern, data-driven volcanology. It demonstrated exactly how a singular, localized volcanic event could produce measurable worldwide atmospheric and climatic effects. The insights gained from analyzing the aftermath of Krakatoa fed directly into the rigorous, data-driven fields we rely on today to monitor our planet's climate.
But here is the truly chilling part of the history we're exploring today. The story didn't end with a Royal Society report in 1888. We didn't just learn a scientific lesson, build better instruments, and close the book on the sun to straight.
No. Geology operates on a timeline that is entirely indifferent to human history. The volcanic complex beneath the sun to strait remained highly active.
It wasn't done.
Not at all. The massive magma chamber that had emptied and collapsed into a caldera in 1883 slowly, relentlessly began to refill from the mantle below. And in 1927, decades after the original island had destroyed itself, submarine eruptions began to break the surface of the ocean.
It came back.
A new volcanic cone emerged from the sea, rising out of the exact same collapsed caldera.
And locals named it Krakatoa.
Yes. Krakatoa, which translates to the child of Krakatoa.
It sounds like the ominous sequel to a horror movie. And the child hasn't been sleeping. It's been growing.
It has been highly active. Krakatoa has continued to grow, building its cone higher and higher and erupting periodically for the last century. It is a stark physical reminder of the ongoing unresolved threat in the region.
Yeah.
And tragically, this isn't just a historical footnote. As recently as December 2018, Krakatoa experienced a significant, highly deadly eruption.
And history repeated itself in the most heartbreaking way possible.
During that 2018 eruption, the structural integrity of the new cone failed. A large portion of the volcano's flank collapsed into the sea.
Oh, no.
Which is the exact same physical mechanism of displacement that occurred in 1883, albeit on a smaller scale. And just like in 1883, that sudden mass entering the ocean generated a localized tsunami that struck the coastlines of Java and Sumatra at night.
It killed over 400 people.
Yeah.
Struck the exact same coastlines using the exact same mechanism. It really makes you reflect on the sheer stubbornness of the planet.
It really does.
The Earth relentlessly rebuilt its own weapon in the exact same spot, completely defying all of our human attempts to move on from the history of 1883. We mapped the strait, we studied the magma, we built global scientific networks to understand it, we had satellites watching it. And yet, the flank still collapsed, the ocean still rushed in, the waves still rose, and the water still took lives.
It is a profoundly humbling realization. We can understand the mechanics of the Earth better than any generation before us. We can track the atmospheric pressure waves. We can analyze the chemical composition of the ash in the stratosphere. And we can communicate at the speed of light.
Right.
But we are still fundamentally, physically vulnerable to the immense raw power of the planet we live on. The child of Krakatoa is a monument to that enduring vulnerability.
So, as we bring all of these threads together, the scale of what we've unpacked in our deep dive today is just staggering. We started with a mysterious boom on a remote island, and we ended up rewiring human consciousness.
We are looking at a singular historical event that exists on three entirely different scales simultaneously.
First, at the most intimate and devastating level, Krakatoa was a regional human tragedy. Tens of thousands of lives were lost, Entire communities and generations erased, not by a towering inferno of magma, but by a silent, unstoppable wall of water. It is a somber reminder that the greatest danger of a volcano can often be the ocean that surrounds it.
Second, it was a planetary-scale physical event. The sheer kinetic energy of the eruption struck the atmosphere so violently that it rang the Earth like a bell.
Literally.
It produced a pressure wave that circled the globe multiple times, injected aerosols that measurably altered the global climate, painted the skies of the northern hemisphere with surreal colors, and generated the loudest acoustic event ever recorded by human ears.
And finally, it was a profound turning point in human communication and media. Because of the newly laid undersea telegraph cables, Krakatoa was the exact moment humanity was plugged into a global nervous system. It was the birth of breaking news.
The world irreversibly shrank in 1883. The distance between a devastating disaster in the Indian Ocean and a curious reader in London or New York was no longer measured in months of dangerous sailing, but in minutes of electrical pulses traversing the abyssal plains.
Which brings me right back to you, the listener. Krakatoa was the first time in human history that everyday people learned about a horrific mass casualty disaster on the other side of the world almost immediately.
It changed our brains.
It completely set the precedent for the modern, hyper-connected world we live in right now. A world where our phones constantly vibrate in our pockets, alerting us to tragedies, storms, and suffering thousands of miles away, events that we cannot physically stop, that we have no localized control over, but that we are forced to witness and process in real time.
It's a lot to carry.
So, as you go about your day today, and you inevitably feel your phone buzz with a news alert or a push notification from some distant corner of the globe, consider this. Did the invention of global breaking news in 1883 make humanity more deeply empathetic to the suffering of strangers? Or did it just plant the very first seeds for the overwhelming, paralyzing information fatigue we all feel today? Something to think about. We'll leave you to ponder that.